Let's talk about factors that do affect enzyme activity. Yes, we have seen properties of enzymes, and basing on those properties of enzymes that we've talked about, you have seen that enzymes, they are proteins in nature. Enzymes, they are affected. They are denatured at high temperatures, inactivated by, and stuff like that. So therefore, we can get factors which can affect the rate at which an enzyme controlled reaction is going to take place. So these are the factors. They are not few, but they are not many, and they are so easy. So number one, we have temperature, and I think this is the main factor. Temperature. That's why you do carry out homeostasis. Temperature. We are going to see. Then we have the amount of water available, because you know that most of these enzymes, most of them, they do carry out hydrolysis reactions. Hydrolysis reactions, apart from some few like ligases, diases, and kinases, I think. But even kinases, they also do carry out hydrolysis reactions. So water must be available, okay, for the enzyme to be effective. Then the pH, the concentration of the substrate, the concentration of the enzyme, the inhibitors together with our end products, they also do affect the same. Then the activators, and finally radiation. So these are the factors that do affect the enzyme activity. And by the way, this is the cheating code. You must know how to explain how each factor here affects enzyme activity. Explain how each factor affects, and with ease. There shouldn't be any hardships. With ease. Okay?
Teacher,
Yes.
how does radiation affect the enzyme activity?
How does radiation affect the enzyme activity? I hope it is there in the slides. We shall find it.
And
Okay?
how do the end product, yes, and how do the end products affect uh, yeah, the end products and the inhibitors?
Okay. Okay, that's a good question. I That's what is in your mind now. You are asking yourself that how does that, how does this affect enzyme activity? Which is good. But the end products, together with the other inhibitors, they all affect enzymes in the same way. Whereby here we talked about the end product inhibition. End product inhibition. So if the end products do accumulate, for instance, then they are going to inhibit the enzymes, so that you reduce the rate of enzyme activity, so that you produce less products at that particular moment, or no product is formed even. Okay? Yes. But if the products reduce, then you're going to form, you won't inhibit the enzymes, and so more products are going to be formed. We are going to we talked about end product inhibition. Okay? Yes. So you can find out, you can go and watch our video. Okay? And enjoy that. So let's talk about each factor now. Let's start with substrate concentration. Now with substrate concentration, it refers Now substrate refers to amount. Substrate, it is food for enzyme. Let me just summarize this as food for enzymes. So the amount of a given substrate in that reaction vessel, in that vicinity, affects how the rate of enzyme activity is going to vary. Whereby at low substrate concentration, you can have a look at this graph. At low substrate concentration, the rate of enzyme activity is very low. Let me teach. I use the graphs because I want to expose you to graph work. Somebody wants to say, at low substrate concentration, the rate of enzyme activity increases, right? That is wrong. At is at a point here. You have no increase nor decrease here. Okay? At that point. So at low substrate concentration, the rate of enzyme activity is low. But as substrate concentration increases, then the rate of enzyme activity also increases rapidly. You can have a look. You can have a look at this graph. But it won't increase forever and ever. It will increase and finally becomes constant. Okay? And finally becomes constant with further increase in the substrate concentration. Now why? Now we saw that from the lock and key hypothesis. For an enzyme to catalyze a given reaction, but I gave you an assignment, read about the Michaelis-Menten kinetics. Did you? I just wanted you to read, not calculating. Ignore those calculations. So from the Michaelis-Menten kinetics, it tells us that for an enzyme to fully catalyze a given reaction, then that enzyme must fully collide with the substrate molecules. Let me write substrate. The enzyme must collide with a substrate molecule to form an enzyme substrate complex, okay, that must dissociate to give us the products plus our enzyme, and the enzyme remains intact and unchanged. But now the science is here. For the enzyme to collide with the substrate molecules, then it means you must have enough enzymes, you must have enough substrates, and the two must be in proper orientations for them to successfully collide to form products. Now, at low substrate concentration, however much you have more enzymes, but the substrate is very low, the chances of collision between these substrate molecules together with the enzyme molecules is very low. So as a result, the rate at which these enzymes will collide with the substrates is going to be low. Hence, the number of products formed per minute is going to be low. Hence, the rate of reaction is going to be low. But as the substrate concentration increases, then the number of collisions, the chance of colliding, the chance of an enzyme to collide with a substrate molecule is going to be high, or is going to increase, so that at any time t, the enzyme molecules will be colliding with the substrate molecules to form an enzyme substrate complex, which can now dissociate because the energy developed in those collisions is going to be high, of course, which will now dissociate to give you the products. So the number of products formed per minute is going to be high, and the rate of reaction becomes high. But it won't increase forever and ever and ever and ever. Amen. No. You reach a certain concentration where further increase in the substrate molecules does not increase the rate of reaction. Why? Because at that beyond that substrate concentration, at any time t, all our enzymes will be saturated. Saturated, this is what I'm talking about. Saturation point, saturated. All enzymes active sites will be saturated with the substrates. So even if you increase like how, the rate cannot increase. Okay? Because if all active sites are saturated, then for another substrate to bind to that very enzyme, then the enzyme substrate complex must first dissociate to give you the product and the enzyme back. But before it dissociates, then you cannot bind. So therefore, if enzymes are saturated at any time t, then you cannot expect an increase with further increase in enzyme activity. However, when we add there some enzymes, this is to confirm that it's really substrate concentration was overwhelming. If you add there some enzymes at this point, you will see some reasonable increase in the rate of reaction, because you are now increasing the number of active sites. And so by increasing the number of active sites, you increase the chances of collision, you increase the chances of forming the enzyme substrate complex, you increase the number of products formed in 1 minute. Hence the rate becomes high. But it will also finally become constant with further increase in the rate of enzyme, with further increase in the substrate concentration. So basically, guys, that's how simple it is. If there are questions, please, you are free to hit the chat box or